Andre's coin jar contains 85 cents. There are no quarters or pennies in the jar, so the jar has all nickels, all dimes, or some of each. Now, following along in your guided notes, the very first thing we're going to do for number 1 is we're going to write an equation that relates to the number of nickels, n. So let's go ahead and let n be our number of nickels. And the number of dimes, d, so let's let d equal the number of dimes. And the amount of money in cents in the coin jar. So we know that we have 85 cents. And we know that the value of a nickel is 5 cents. So our equation could be 5 cents. I'm going to write that a little neater. 5 cents per nickel plus 10 cents per dime will equal a total of 85 cents. Now for part 2, we're going to graph our equation using Desmos. So we need to open up desmos.com and then go ahead and choose the calculator or the graphing. And let's go ahead and let our nickels be our X value and our dimes be our Y value. And the great thing about Desmos is we can go ahead and just type our equation in without having to put it into Y equals form. So we can put 5x plus 10y equals 85. Now, we may want to zoom this out a little bit. It doesn't really make sense for us to see negative values, so let's go ahead and do that. I'm going to just change my window a little bit here so that I'm just looking more at positives. And then we can go ahead and sketch this graph onto our guided notes. So you have a Desmos graphing screen in your notes so that you can go ahead and put this in there. Now, a couple of things that may make this a little bit easier is if we try to look at some points. So we have a point at over 5 up 6. That might be a good point, reference point to use. And then on our x-axis, if we go over 15, 16, over 17, up 0. So our x-intercept might be another good point to use to make a nice sketch. So I went ahead and took a screenshot of that and put it here. And then be sure to label our axes. So because I used X for my nickels, I want to go ahead and make sure that I label that. And then I used my y-axis for dimes, so I want to go ahead and make sure I label that my y-axis is dimes. So I'm going to go ahead and I'm not going to try to write it sideways. And I can see my graph here. So then for question number 3, how many nickels are in the jar if there are no dimes? So if I have 0 dimes, what would I have for nickels? So if I put in a 0 for dimes, that's going to be this intercept right here. And so if we count over, that's 15, 16, 17. That would be the intercept. 17, 0, meaning 17 nickels, 0 dimes. So 17. And question number 4, how many dimes are in the jar if there are no nickels? Now, this question, there is a y-intercept. We can see it right here. But notice that that y-intercept is not on a whole number. And if we think about that, if I put in a 0 for n, I have 85 divided by 10. I'm not going to get a whole number of dimes. And so when we talk about how many dimes are in the jar if there are no nickels, that's not really a possible reasonable answer. So in this case, while we do have a mathematical answer here, we do have a y-intercept of 8.5, we can't have 8.5 dimes. And so in this case, our answer to this question of how many dimes are in the jar if there's no nickels, we would say it's not possible. So it's not possible for the jar to have 0 nickels. If the amount is 85 cents. Now the really interesting thing about this is we just talked about what if we had all nickels, what if we had all dimes. Along this line would represent all different combinations of different ways the coin jar could have 85 cents if it contains different amounts of nickels and dimes. So for example, this point right here would be if we have 5 nickels and 6 dimes. And then we could extend this problem if we wanted to include other denominations of money. So if we wanted to say, what if we could have quarters? What if we could have pennies? And then we can start to imagine the different possibilities as well.